The next lesson in Topic 9 is 9.3 Ellipses. We'll look at the unique features for an ellipse and how they're different from a circle. To identify an ellipse by equation form, you're going to have addition with your ax squared and by squared terms. But what makes this an ellipse and not a circle is that the coefficients a and b will be different. Standard form for an ellipse has two parts. We'll first look at when your center is 0, 0, similar to what we did for circles. Over on the right, you'll see we have two forms for an ellipse. An ellipse can be vertical or an ellipse can be horizontal. The formula for an ellipse is kind of like the formula for a circle. On the left side, you'll have your squared x and y terms. But notice they're in fraction form. Now you'll have numbers underneath x squared and y squared. On the right, the key thing to note is it's always equal to 1. It's not r squared on the right-hand side. We won't have a radius for ellipses since they aren't equidistant from the center in all directions. A key thing to note for this standard form is that you see a squared and b squared underneath x squared and y squared. A squared is always going to be the bigger term, and that helps identify your major axis. Notice in that first equation, a squared is underneath y squared. That means the major axis is the y-axis. And if you look at the picture, the y-axis is taller than the x-axis is wider, so that would be your major axis. Notice we also have major vertices and minor vertices, and there are 4 of them, just like there were for circles. But what makes this unique is instead of doing the square root of r, the square root of r squared for the radius, we're going to do the square root of a squared for the major vertices. We're going to count up and down. And then the minor vertices would be the smaller kind of other direction. So notice the number that's underneath x is that b squared. We're going to count by the square root to the left and to the right. So for your major vertices on a vertical ellipse, we're going to go up and down from the center. For the minor vertices on a vertical ellipse, we'll go left and right. Oops, that's supposed to be left. Let's try that again. We'll go left, there we go, and right. And then we draw that oval shape through those 4 total vertices. The trade-off for a horizontal ellipse is now the a squared term is underneath x. That means your major axis is going to be the x-axis. So now for your major vertices, you're going to go to the right and to the left the major axis amount, whatever the square root of a squared was. For those minor vertices, the number that's underneath the y squared, that'll be the smaller number, you'll count up and down by that square root. And then you kind of do your horizontal ellipse in that direction. All right, let's see if we can put this to the test. To graph an ellipse, you have 3 key features. You want to determine your center. You want to determine where the major vertices are and the minor vertices, just like we talked about up above. It also says major and minor axis. We'll focus on that major axis up above. We won't have to determine the minor axis each time. In our first example, we have x squared over 29 plus y squared over 9 is equal to 1. This is in standard form for an ellipse centered at 0, 0. And we know it's 0, 0 because nothing's being added or subtracted to the x squared and y squared term. Very similar to circles in our last lesson. So because of the plane x squared and y squared, nothing's being added, we know that our center will be right at 0, 0. So that's pretty easy to determine. Also note, let's see, if we look at our equation, we have x squared over 25 plus y squared over 9. Our major axis is going to be the x-axis because 25 is greater than 9. That means we're going to take the square root of 25 and go up and down 5. That'll help us with our major vertices. I'm sorry, not up and down. If it's the major axis is the x-axis, we'll go right and left. So that means we're going to go 5 to the right and 5 to the left from our center. Let's go ahead and plot our center and those 2 major vertices. like so. To do the minor vertices, we look at the smaller number. That's 9. The square root of 9 is 3. So for our minor vertices, since that's under the y value, we'll count up 3 and down 3 from our center. If we count up 3, we'll just be at 0, 3. And if we're down 3, that'll be 0, negative 3. Let's plot those 2 points. Up 3 and down 3. So now what you want to do is draw a curve through those 4 vertices. It'll be more oval shaped than it would be for your circle. Go ahead and sketch that ellipse, and we'll go on to the next example. And again, we're just trying to draw them as accurately as possible, given the conditions for me writing on my iPad. So just try to make it a smooth kind of curve through those 4 vertices. Let's try the next one. X squared over 12 plus y squared over 36 is equal to 1. Again, we know that our center will be at 0, 0 because nothing's being added to the x squared and the y squared. So let's start there. Our center is 0, 0, and you can write it wherever it fits on your paper. And now we know the major axis is going to be the y-axis this time, because 36 is greater than 12, and 36 is underneath the y value. So that was our step 1. Step 2, to get our major vertices, the square root of 36 is 6, so we're going to count up and down from our center. If we count up, we'll be at 0, 6, and if we count down, we'll be at 0, negative 6. Let's plot our center, 0, 0, go up 6, and down 6. Now, for our minor vertices, we have the square root of 12, and that's not a perfect square. However, the square root of 12 can break down into 4 times 3. So the square root of 4, if we want to reduce this radical or square root, would be 2 square root 3. Now that's not going to be super great for our graphing purposes, but that's how we'll write our ordered pairs. Our minor vertices are going to be on the x-axis, so we have to count right and left. If we count to the right, that'll be 2 square root 3, comma 0. If we count to the left, that will be negative 2 square root 3, comma 0. So if we're trying to determine what that equals, we're going to have to try to approximate maybe what's happening there. The square root of 12 is going to be between 3 and 4, so we'll approximate it at about, we'll say like 3.4 or 3.5, somewhere in there. So go 3.4 units to the right as best you can, and then do the same thing in the other direction on the left. You can see that this is going to be a taller shaped ellipse. That means it's a vertical ellipse. Go ahead and connect those 4 vertices with a smooth curve. And hopefully your shape looks something like this one. These are when your ellipses are both centered at 0, 0. Down below, we'll look at creating translations. When you have something added or subtracted to the x and y squared terms, you've translated your ellipse. You'll still find the same types of key features, it just takes a little bit more effort to get those ordered pair values. Now our center is going to be at HK instead of 0, 0. Remember, it's always the opposite sign for both x and y when it's in the parenthesis. And again, to determine if it's vertical or horizontal, remember a squared is always greater than b squared. To translate your center, always look for the bigger denominator. Notice in our first example, we have x minus h squared over b squared plus y minus k squared over a squared equals 1. Notice our center translated to hk. Since the a squared is underneath y, our major axis is going to be the y-axis. For our major vertices, we're going to count up and down a units, which is the square root of a squared, just like we did before. But now we start from that k location. So it's going to look like this: h, k plus a, and h, k minus a. So again, we're still counting up and down a units from our center. Our centers just add a new location. To get those minor vertices, since the smaller number's under the x, now we're going to take the square root of b squared and go right and left. So from the center, we'll go h plus b, and then h minus b. And that's how you'll determine those 4 key vertices for your ellipse and sketch the curve with that translated center. Now, if we reverse that and make it horizontal, your center will be HK still, but now the major axis is going to be the x-axis. And since a is underneath x squared, we're going to go a units to the right and a units to the left, so that'll be h plus a and h minus a for our major vertices. To get those minor vertices, we're going to go up and down b, since that's underneath the y squared term. So that will be k plus b and k minus b. I know those ordered pairs look really strange, but once we plot them, they're pretty easy to do. Let's flip it over and try a couple of those examples. For the following examples, graph each ellipse. State the type of ellipse, either vertical or horizontal, the major axis, center, and define the vertices. In our first example, we have x plus 2 squared over 9 plus y minus 1 squared over 16 equals 1. Now, the first thing we're supposed to do is state the type of ellipse. That means, is this going to be vertical or horizontal? Well, if we look at the bigger number, 16 is greater than 9, and that's underneath the y variable. That means this is going to be vertical. So now let's find our center and our vertices. Our major axis, let's do the things in order, my goodness. Our major axis is going to be the y-axis. So that means this ellipse will look taller than wider. Let's see. Step 1, find our center. Now, if we have parentheses, we have to do the opposite sign for both x and y. That means our center will be -2, +1. To get our major vertices, we know that the square root of 16 is 4. So from the y coordinate of the center, we're going to add 4 and subtract 4, since y is the major axis. This means we'll do -2, 1 plus 4 and -2, 1 minus 4. Well, -2, 1 plus 4 is going to be -2, 5. Hang on, I'm going to try to get that to fit right there. So that would be -2, 5. And then -2, 1 minus 4 would be -2, -3. Let's go ahead and plot all of that. So we have -2, 1 for our center. And then we're going to go up 4 and down 4. So if we count up 4, we'll be at -2, 5. Down 4, we'll be at -2, -3. All right, let's do our minor vertices. They're going to be in the other direction. Our number underneath x squared is 9. So the square root of 9 will be 3. And that means because it's under x, we'll go 3 to the right and 3 to the left from our new center. -2 plus 3 and -2 minus 3. If we go -2 plus 3, we'll be at 1. So we'll be at 1, 1. -2 minus 3, we'll put -5 and then up 1. From our center, if we count 3 to the right, we're in fact at 1, 1. And if we count 3 to the left, we're at -5, 1. Put that dot in there a little bit better. Well, maybe not so much. Whoa, okay. We'll try that again all together. Okay, so now our task is to draw a smooth curve through those 4 vertices and try to get the shape of this vertical ellipse. And the more times I circle around those points, the more crazier my shape gets. So hopefully your shape looks something like this. All right, let's try the example on the right. For our example on the right, we have x plus 3 squared over 25 plus y plus 2 squared over 9 is equal to 1. Taking a look at the numbers underneath the x squared and y squared terms, notice the number underneath x squared is 25, and that's bigger than 9. That means this ellipse should be horizontal. And our major axis will be the x-axis. And that's where our major vertices will be located. So our center, remember we're going to do the opposite sign of our parentheses. Notice we have x plus 3 and y plus 2. That will make our center -3, -2. And since our major axis is the x-axis, to get our major vertices, the square root of 25 is 5. We're going to go 5 to the right and 5 to the left. So if we do -3 plus 5 and -3 minus 5, those will be our major vertices. -3 plus 5 is 2. So we'll be at 2, -2 for one of our vertices. -3 minus 5 is -8. So -8, -2 will be our other major vertice. Let's plot these three coordinates. Our center is -3, -2. And our major vertices, if we count 5 to the right, will be at 2, -2. 5 to the left from the center will be at -8, -2. Let's go ahead and determine those minor vertices. The number underneath y is 9. If we take the square root of 9, so far these are working out really nice for us. We'll go up 3 and down 3 from our center. If our center is at -3, -2, we'll count up 3 and then down 3. If we count up 3 from the center, we'll be at -3, +1. If we count down 3, we'll be at -3, -5. So from our center, go up 3 and down 3. And there are our boundary coordinates for this horizontal shaped ellipse. All right, go ahead and sketch. And hopefully your ellipse looks something like this when you're done. Last but not least, similar to circles, you can write the equation for an ellipse if it's in standard form for a second degree function by completing the square. What makes ellipses a little bit more challenging is that when A or B are present, we have to factor them out first. Remember, completing the square only works when your squared term has a coefficient of 1, but remember, ellipses have different values for A and B, so it might be an instance where you have to factor that out first. We're only going to do one of these because there's quite honestly not enough room based on all the work we have to do. So I'm just going to cross off the second one for now. And we're going to use all the space to complete the square for the first one. Sorry about that. All right, let's go. We have 2x squared minus 12x plus y squared minus 2y plus 15 equals 0. To complete the square, like circles, we're going to group our x squared terms together and group our y squared terms together and move that constant to the other side. So notice we have 2x squared minus 12x plus we have y squared minus 2y is equal to -15. So we know this is an ellipse because we have a 2x squared, or not a 2x squared, because we have 2x squared, and then we have plus y squared. So we have two squared terms, there's addition between them, and the a and the b values are different. So now, what makes this tricky for the x's is that we've got that 2 out in front of x squared. So we have to factor the 2 out before we complete the square. If we factor out 2, we get x squared minus 6x. So now we just take half of -6, and that's -3. Square -3, and we get +9. So far not so bad. But there's that 2 out in front, and if we add 9 to the inside, x squared minus 6x plus 9, we have to remember that we have to do 2 times 9, and that's 18. And that's what we add to the other side. So just wrap your head around that for a second. And then we'll factor x squared minus 6x plus 9 would be x minus 3 and x minus 3. So that would be 2 times x minus 3 squared. Okay, the y squared should go a little bit faster. There's no number in front of y squared to factor out, so we can just go ahead and do half of -2, and we get -1. -1 squared is +1. And we can go ahead and add that right on into the inside. Y squared minus 2y plus 1. And since all we did was add 1 to the parenthesis there and there's nothing out in front, we'll just add 1 to the right. Go ahead and factor. What are two numbers that multiply to get positive 1 but add to get negative 2? Negative 1 and negative 1. So that would be plus y minus 1 squared. Now on the right-hand side, we have negative 15 plus 18 plus 1, which is 4. Now that's where we stopped last time for a circle. But now we have to divide everything by 4. And I'm into my graph a little bit. And this is why we need the space over on the right-hand side. I've got to move some stuff over here. If we divide everything by 4, the 2 out in front reduces that 4 to a 2 on the bottom. So this gives us x minus 3 squared over 2 plus y minus 1 squared over 4 equals 1 on the right, because those 4's cancel out. So now that's all the work we'd need to convert that to standard form. And that's where we're going to stop for today. So go ahead and take your checkpoint quiz.